Hello all, welcome to this presentation. Thanks Christoph for the introduction. I'd like to present you some promising perspectives for electrohydrodynamic printing on nanoscale. I will illustrate that with a couple of examples from recent work we have done at our company. Let me first tell a little bit about the needs behind electrohydrodynamic printing. There are a couple of important applications in large volume industries, like in displays, there's the use of touchscreens for which indium tin oxide is used. One of the hurdles with using that material is that indium is a kind of scarce material, and with the current supply problems, it's difficult to obtain. That causes a need for replacement. And one of the promising alternatives for ITO is silver nanowires as made with electrohydrodynamic printing. There are also a couple of other large industry applications like in the batteries, in the solar industry. But what I would like to focus on in the presentation today is that there are also various interesting applications in low volume but high added value markets, like the one for microfluidics in healthcare. Let me give a bit of more background about that kind of application. I will do that showing examples from work we have done recently with our partner Microtech from Duisburg in Germany. On the picture here in the middle, we show an early prototype of a microfluidic pump as has been made by Microtech. There's a lot of technology in it, but what I like to highlight here is that there's an inlet, there's a channel for a liquid, there's an outlet, and there's a pump made with electrodes. A bit difficult to see on this picture, but the electrodes pull the liquid ahead and make the pump work. Ambition at Microtech is to make this device so small that it can be used inside the body of patients. And as will be obvious from the picture, it is important that the device will be very small for making that possible. This is one of the nice applications where electrohydrodynamic printing can do a lot in a small volume but high added value application. It will be obvious if you make the device small, you will need to make everything on the device, including the electric connectors, very small as well. Electrohydrodynamic printing can allow to bring the width of the wires down from, let's say, the 30 microns as can be obtained with conventional inkjet printing to 1 micron or even less with proper process conditions. Quite a couple of things need to be done for making that happen. Let me tell you a bit about that in the next slide. What needs to be done basically is that electrohydrodynamic printing is made suitable as a submicron additive technology. The working principle for making that possible is shown on the picture here on the right-hand side. A couple of key features in this printing technology are that the needle tip, the so-called nozzle, is placed very close above the substrate. Here we talk about a distance of about 1 millimeter. And what also is very special is that we put a high voltage on the needle, in this case a voltage between 1 and 2 kilovolt. As you will feel, that's a large voltage for such a small distance, so a big electric field will arise. The effect will be that this field will pull the liquid into a very narrow shape, and thus that very thin wires can be printed on this substrate. This enables a direct write patterning with this near field electrospinning. Basically, we can write very small wires over a surface in any direction by moving the printhead over the substrate. With the so-called coaxial printhead, this allows us to make conductive wires. Also, what is important to note is that with printing the wires alone, of course, the device is not ready. We will also need sensor devices, we will need chips, we will need all kinds of interconnections, a battery for making the complete application work. This is why combination with microassembly technologies is important as well. At DoMicro, we make that possible by having a modular printhead, which implies the printhead can easily be taken out and be replaced by other heads for other process operations. A few words about where we are at this moment. The printer as we have developed in the company currently is suitable for R&D purposes, so for doing research work on the kind of application as I just have shown. The picture on the left side shows a close-up of the printhead. It has two so-called syringes, so containers for the liquid to be pumped through the coaxial needle, and under this circle will be the substrate which will be printed on. In the middle picture, we see the nozzle from which a printjet is emerging, in this case a few microns wide. On the right-hand slide picture, I show a silver line with tiny silver particles, and around that is the so-called PO shell for packing this wire in silver. That's the state of the art. There's a lot more which I can tell you about it, but I like to refer you to separate contacts. Be welcome to contact us at any moment through the contact details as they are over here, and of course through the TechBig portal as is available all over the year. Thanks for joining my presentation today. We will be happy to answer any question. Please give us a call or give us a signal, and we'd like to talk to you. Thanks all.